So now let's review rational exponents, what you learned in Algebra 2. So exponential form looks like this. We have a raised to the 1 over nth, and this means the nth root of a. In radical form, this looks like this, the nth root of a. So n is our index, and then a, our base, is our radicand, so our value that's underneath the radical. Next, if we have a to the m over n, so we have still a fraction, but this time our numerator isn't 1. This is the nth root of a raised to the mth power. So n is still our index, so whatever is in your denominator, that's the index. It goes on the outside of your radical. And what's in your numerator, that's what a is raised to. It's the power, that's the degree that your base is raised to. So now go ahead and pause the video here and see if you remember how to simplify these expressions from Algebra 2. So the first example, we're using the product rule here. So we will add our exponents. In order to add these exponents, though, because they're fractions, we need to have common denominators. So here we have p to the 4th times p to the 3 over 2. So here we will get common denominator, so we'll multiply our denominator by 2 to get 4. And whenever we multiply the denominator by, we also need to multiply our numerator by, so 6/4. And let's see if it'll be easier if I write it. Here we go. From here, we're going to use the product rule, so we will add our exponents together. So this will be equal to p to the 1/4 plus 6/4, that's 7/4. If we were to rewrite this as a radical, so in radical form like this, our index is 4, and it's raised, p, is raised to the 7th power. So since it's raised to the 7th power, we could rewrite this as the 4th root of p times itself 7 times. Right? This is how you initially learned. So p times p times p. P times itself 7 times. Right? So this is how you initially learned exponents. Because our index is 4, though, we're looking for groups of 4. So if we see here, we have 4 p's. That means we can say, okay, p, we have 1 p on the outside, times the 4th root of, let's see, we have 1, 2, 3 p's left over, so we multiply those together and say times the 4th root of p raised to the 3rd power. This would be our final answer. So remember, I'm doing this the quicker way, so that's the longhand way, the way that you probably initially learned exponents. The shorthand way is just to divide this value by the index. So here, okay, 7 divided by 4, we have a remainder, but if we subtract 3 from 7, we get p to the 4th power, and then we divide our exponent by the index. So 4 divided by 4 gives us p to the 1st power here. Okay, let's check the second example. So 8x squared, and then all of that raised to its 2/3 power. So here we're going to use the power rule. So step 1 in the power rule is we will raise our coefficient 8 to the 2/3 power. Let's see, 8 raised to the 2/3 power. And I didn't write that very nicely, so let me go back and try again. Okay, and then we're multiplying our exponents here, so 2 times 2/3 x to the 4/3 power. That's it then. So here they both have a denominator of 3, so the index will be 3. It'll be a cube root. 8 squared is what's going to go underneath our radical. And then x to the 4th power. That's a little too long. X to the 4th power. Okay, so 8 squared, we know that is 64. So 64x to the 4th power. Then we need to simplify this as much as we can. We've written it as a radical, but now we just need to simplify. So the cube root of 64, well, 64 is actually a perfect cube, right? Think, what number can we multiply by itself 3 times to get 64? Well, that's 4. 4 times 4 gives us 16. 16 times 4 gives us 64. So we have the cube root of 64. That's going to be perfect. And we'll multiply it times the non-perfect cube root. So this is another way you might have learned exponents. So here x to the 4th, well, 4 is not divisible by 3. It'll give us a remainder, but if we subtract 1, we'll have x cubed, which is, because we subtracted 1, that 1 goes here. So the cube root of 64 is 4, and then x cubed will divide by our index of 3, and then we're left times the cube root of x. So 3 divided by 3 gives us x to the 1st power. Okay. So we have 4 times x to the 1st power times the cube root of x. This is our final answer here. Okay, so the last thing that I want you to work on here is to, if you're given these two functions, f of x is equal to x squared plus 9, and g of x is equal to the square root of x, find each new function and state its domain. So this is going back to this year. Earlier we talked about operations with functions in our unit on polynomials. So go ahead and apply all the rules you've learned now to find each new function and state its domain. So pause the video and try these problems. Hopefully you paused the video, and now let's check your answers in your work. So for part A, we were adding these two functions, f plus g. So if our first function, f of x, is x squared plus 9, we're going to add it with the second function, the square root of x. Now, we don't have any like terms to combine, because the square root of x, if we were to write this in exponential form, it would just be x to the 1/2. Root is 2, so we can't combine any like terms, so we just rewrite it in standard form. So highest exponent power first, which is 2, and then x to the 1/2, and then plus 9. I also, in the directions, asked you to state the domain of the function. Because we have the square root of x, remember we can't take the square root of negative values, so for our domain x must be greater than or equal to 0. Because remember, if we're taking the square root of a negative, it becomes imaginary. That's really for any even power index that you have. So for part B, we're multiplying these two functions, so x squared plus 9 times the square root of x. So in order to multiply them, I rewrote this in exponential form. It was in radical form, so I rewrote it in exponential form. And then just distribute to each term. So x squared times x to the 1/2 power. We need to use the product rule here, so we add our exponent. So 2 plus 1/2 is 5/2. And then 9 times x to the 1/2 power is just 9x to the 1/2. These are not like terms. The exponents are different, so we can't combine them, so we just leave it as it is. Again, our index is an even number, so x has to be greater than or equal to 0. Our last one, c, we're dividing these two functions. So x squared plus 9 divided by the square root of x. We need to rationalize our denominator. So we multiply by the square root of x by our denominator. So this is the same thing that we just did in part B where we're multiplying. So again, we get x to the 5 halves plus 9x to the 1 half, and then square root of x times itself just gives us x. For our domain this time, it's just x is strictly greater than 0. Because we have an x value in our denominator, x cannot be equal to 0.